In ballistics, Newton's third law is absolute. Every action requires an equal and opposite reaction. When a high-velocity projectile strikes a physical target, that kinetic energy transfers immediately as a shockwave, powerful enough to shatter bone and liquefy tissue. Yet when we observe Subject 011 taking heavy gunfire, he remains completely unaffected. He absorbs direct hits without breaking his stance, presenting a physical impossibility under standard laws of motion. The bullet's kinetic energy is completely consumed upon impact. We classify this occurrence as a zero transfer event. We have to stop thinking of this as armor. Traditional armor, like steel plating or Kevlar, merely redistributes an impact across a wider surface area, which still results in severe blunt force trauma for the wearer. This material operates as a molecular kinetic sink. It actively eats momentum. To understand how he survives, we need to run a subatomic autopsy on the vibranium weave to see exactly how it defies physics. Pushing past the macroscopic bullet strike, we hit a structural paradox. Normally, when you strike a solid metal, it absorbs the violent vibration by either ringing or shattering. This atomic diagram illustrates the difference. Left, standard atoms oscillate, passing the kinetic wave along. Right, vibranium's non-resonant atomic lattice remains rigidly locked. When force is applied, instead of rippling outward, individual nodes trap incoming momentum by spinning rapidly, entering a quantum spin state. The physical sensation shifts for the wearer. Instead of a blunt impact, the suit becomes physically heavy with trapped kinetic energy. The vibranium habit functions as a solid-state energy capacitor, capturing the raw momentum of hostile fire directly inside its subatomic bonds. This capacitor model introduces a fatal flaw. Trapped kinetic energy naturally translates into extreme heat. Containing that much mechanical friction should quickly cook the pilot alive inside. To survive the temperature spike, the weave employs an internal countermeasure called thermal-kinetic conversion. This vector model maps the mechanical spinning energy as it is actively siphoned off by micro-capacitors woven directly into the fabric. They translate the dangerous molecular vibration into a contained, stable electrical potential. That current feeds into a buffer field. The suit's signature purple luminescence is actually the visible discharge of excess photons, bleeding off light as the buffer reaches its absolute storage limit. T'Challa empties the buffer manually. By triggering a lattice release, he dumps that stored electrical charge outward through his physical strikes. This is a closed-loop system. He weaponizes the combined kinetic history of every bullet he has absorbed. To find a material's breaking point, we can run a forensic stress test and calculate the exact mathematical threshold required to overwhelm the sponge. This chart tracks lattice capacity. At 90% charge, a massive kinetic influx, like a tank shell, redlines the gauge. Overloaded molecular bonds can no longer contain the quantum spin. The structural nodes shatter, causing spontaneous decohesion in a 360-degree vector explosion. This catastrophic failure, a saturation backfire, triggers an inward shockwave of his own collected momentum. It erases him at a structural level. This is his operational reality. He is forced to constantly expel energy by hitting back, navigating a brutal mathematical limit to keep his armor stable. Balancing his life on a molecular knife's edge requires mastering materials engineering. He wears a highly volatile, high-velocity bomb, surviving by turning his defense into a weaponized shadow.